August 1, 2012, market opens at 9:30 a.m. One server out of 8 is running old code. Code that was supposed to be dead, 9 years old code. In 45 minutes, the company loses $440 million. That is about $163,000 every second. The team was not stupid. They were experienced. They were fast, but they were fixing the wrong thing. Not because they were bad engineers, because every person in that room was looking at the wrong problem. That is what we are talking about today. Today, I want to show you something. The more experienced you are, the more confident you become when you are wrong. And I'm going to give you simple tools to catch yourself when it gets expensive. This is not about being more careful, it is about building a system that protects you from your own brain. Okay, let us start with the science. This is not about being lazy or careless. This is a real thing happening in your brain. It is measurable and it hits experts harder than beginners. I wish someone showed me this many years ago. There's a name for this, Einstellung effect. Here is what it means in simple words. Your first idea blocks you from seeing better ideas. I'll repeat. Your first idea blocks you from seeing better ideas. Even when you think you are looking for alternatives, you are not. Your brain already decided. They proved this with eye tracking. Experts do not even look at the area where the better answer is. It is not a willpower problem, it is not a seeing problem. Your brain hides the answer from you. This is the part that scared me. It is not that experts look at the better answers and say no. Their eyes skip over it completely, they do not see it. And the worst part, they believe they checked everywhere. I have watched this happen during incidents. Senior engineers staring at logs, completely missing the one line that explains everything because their brain already picked a theory. Look at this. When you face a problem, your brain does pattern matching. I've seen this before. At 80% of the time, it works. Your gut feeling is correct. But 20% of the time, the situation looks familiar, but it is actually different. And that is when you get a wrong answer with full confidence. Not uncertain, confident, and wrong. I've I've been that person many times. Some numbers. 70% of wrong decisions developers make come from cognitive bias, not from the lack of knowledge. Those wrong decisions eat 25% of your working time, 1/4. Just undoing things your brain tricked you into doing. And 60% of the beginners, when they see a problem, they pick the first idea and never look back. If you have ever spent a whole afternoon debugging, then realized you were in the wrong file, this is why. And here is what makes it dangerous in real work. Time pressure makes all of this worse. When you are stressed, when there is a deadline, when production is down, your brain takes more shortcuts. You anchor harder on your first guess. The moment you feel, I need to move fast, that is exactly when you should stop and check your assumption. I have lived this in every major incident. The urgency feels real, but the urgency is also the trap. Now, let me show you this same pattern in three of the biggest engineering failures in history. Same brain trick, different years, different industries. Once you see it, you will see it everywhere. June 1996, European Space Agency. They launch a new rocket, Ariane 5. They reuse software from the old rocket, Ariane 4. The code worked perfectly for years. 37 seconds after launch, the rocket explodes. Why? The new rocket flies faster. The old code assumed it would never go that fast. A number overflowed. Nobody checked the assumption. Proven code. Nobody questioned it. And $370 million gone. Threat 25, another example. A radiation therapy machine. Operators reported problems. The machine was giving too much radiation. The manufacturer said, operator error. For 2 years, they said this. 6 patients got massive overdoses, 3 died. The real problem? The manufacturer had removed hardware safety checks and trusted only the software. The software had a race condition. But they were so sure their code was correct, they could never hear the evidence. I have seen a smaller version of this. Teams ignoring bug reports because the code handles that case. Look at the pattern. What they thought the problem was, no problem, code is proven. Operator error, navigation issues, right? What the problem actually was, assumptions, nobody checked. Safety layers, nobody verified. Teams not talking to each other. The scary bugs are not in your code, they are in the gap between what you assume and what is actually true. Before I continue, I want you to think about something. Your last hard debugging session, the one that took hours. Were you testing if your theory was wrong, or were you looking for proof that it was right? Be honest. I know my answer, and it is uncomfortable. Now, here is something happening right now. Same trap, industry scale. Most people have not noticed yet. The data came out in the last year, and it is surprising. A proper experiment, a randomized controlled trial, experienced developers. They thought AI tools made them 24% faster. After finishing, they estimated 20% faster. Actual measurement, 19% slower. 43 percentage points between what they felt and what actually happened. They felt productive, they were not. I've caught myself doing the same thing, feeling fast while going in circles. It is not just individuals. Google's Dora report, biggest annual survey of engineering teams, found that most AI use gives slightly better good quality, but delivery stability goes down by 7%. Throughput goes down 1.5%. Individual numbers look good. System numbers get worse. Same pattern, right? Fixing the local problem while making the global problem worse. 400 plus companies tracked over 15 months. AI tool usage went up by 60%. Actual output up only 8%. The industry promised 10x gains. Reality is 8%. Why? Because writing code was never the bottleneck. We solved the wrong problem at industry scale. Developers have spent 60 to 70% of their time understanding code, only 5% editing it. So making editing faster is fixing the wrong thing. The bottleneck is understanding. Use AI to improve your understanding, right? Use AI to improve your domain understanding. Use AI to understand your system thinking, attitude, mindset. So basically, it is figuring out what the problem actually is. That's what makes difference. Same installing trapped. We assumed coding is slow without checking if that was actually true. Software is not the only field with this problem. Medicine, aviation, infrastructure, they all hit this wall. And some of them found solutions. Let us take these. Let us take their ideas. Right. The best solutions I found in my career came from outside our industry. Medicine. 795,000 Americans die or get permanently disabled from wrong diagnosis every year. Doctors, people who study diagnosis for 10 years, get it wrong 11% of the time for serious diseases. This is not a software problem, this is a human brain problem. And medicine has been working on solutions longer than us. Medicine did not say try harder, or be more careful, right? They built a rule into the process, a diagnostic time out. So before you commit to a diagnosis, you stop and ask, what else could this be? Not because you are unsure, because being sure is the risk. I started doing this during incidents a couple of years back. It changed everything. Netflix did not build a better database. They changed the question. Old question was, how do we prevent database failures? New question, how do we survive failures? That one reframe created chaos engineering, an entire discipline because someone asked the right question. The best defense against big failure is to fail often. Read that again. The best defense against failure is to fail often. They stopped trying to prevent failures. They started making failures survivable. That is what good problem framing looks like. Every field that solves this problem solved it the same way, not by telling people be more aware. That does not work at all. Research shows awareness alone has almost no effect. Telling engineers watch out for bias is like telling someone just be taller. You need to change the process, not the person. That took me years to understand. Think about your last production incident. How fast did your team commit to a theory? Did anyone say, wait, what if it is something else? Or did everyone jump on the first explanation? Most teams I have worked with, including mine, skip this step completely. Every time it cost us. You understand the trap, right? You have seen it at massive scale. Now, what do you actually do about it? These are things you put into your process, so you do not need to rely on willpower. Willpower fails under pressure, process does not. The skill gets more valuable every year. When you are a junior, it saves you hours of debugging the wrong thing. When you are mid level, it saves your team weeks of building the wrong feature. When you are senior, it saves your company from $1 million mistakes. The people who ask, what else could this be? They rise faster than everyone around them. I have watched it happen again and again. 4 steps. It takes 2 minutes. Step 1. Write down your hypothesis. Say it out loud. If you cannot state it clearly, you do not actually have one. Step 2. Ask, what would prove me wrong? Not what would confirm me. What would break my theory? That is the question. Step 3. One other explanation. Just one. Step 4. Check that alternative before you go deep on your first guess. 2 minutes. That is all, right? I do this every time now. It has saved me a lot of hours than I can count. Here is how I decide when to trust my gut and when to question it. If you are in a familiar area and the situation is normal, trust your gut. It is probably right. If you are in a familiar area but the situation is new or unusual, verify. This is the danger zone. This is where night capital was. If everyone is unfamiliar, question hard. If everything is unfamiliar, question hard. Slow down, get help. The danger zone is when things look familiar but something is different. That is where brain tricks you the most. This is the debugging loop I use. Hypothesize, say what you think is wrong. Right? Predict. If you're right, what specific thing should you see? Test. Go look for that specific thing. Falsify. Try to break your own theory and then repeat. This is how scientists work. It is the opposite of search around and hope something looks good, something looks wrong. I switched to this 5 years ago and my debugging time dropped by half. 3 things to add to your process, right? Pre-mortems. Before you start, ask, how could this go wrong? This creates alternatives before your brain locks in. Pair debugging. Not because you need help, because a second person is not trapped by your first theory. They can see what you cannot. The sniff and check. Ask yourself, is this a complicated problem with clear cause and effect? Is it a complex problem where things are connected in the ways I cannot predict? Different problems need different tools. Five whys work for complicated problems. For complex ones, you need to experiment, not analyze. Let me close with three things. If you remember nothing else from today, remember these. One, your expertise can blind you. That is not a weakness, it is how brains work. It is measurable and unconscious. Two, the bottleneck is never fixing the problem, it is always finding the right problem. Diagnosis takes most of the time, always. Three, what else could this be? Make it a habit, put it in your run books, say it in your incident channels, ask it in design reviews, right? Do not rely on remembering in the moment. Build it into your process. Charles Kettering, head of research at General Motors, 186 patents. His most important insight was not about engines. A problem well stated is a problem half solved. The other half, the fixing. That is the easy part. It is the stating, framing, that is where we fail. And now you know why. Let me take you back to where we started. Night Capital, the eighth server, the old code. Everyone said we should have checked all eight servers, but that is the surface problem. The real problem, nobody in that company ever asked what happens if we get this wrong. No kill switch, no safety check, dead code sitting there for 9 years. The question that would have saved $440 million was never asked. Do not let that be your story. That is what we covered today, right? Why smart people solve the wrong problem, the pattern across billion-dollar disaster, the same trap playing out right now with AI tools. Right? A simple structural tools you can use starting tomorrow. Not awareness, structure. That is the difference between knowing about this trap and actually escaping it. If this was useful, subscribe. I make these because I wish someone showed me years back. So next time, hypothesis driven debugging. See you then.